It says a cheetah is the world's fastest land animal. Great. It can travel at up to 70 miles per hour. Okay, so a cheetah is sitting under a tree, sprints towards its prey at 70 miles per hour. It runs back to its neutral spot by the tree at a modest 40 miles per hour. The cheetah is embarked on a round trip, point A to point B. Can we say that the cheetah's average rate was 55 miles per hour? Okay. So the scenario here is A and then B, and the cheetah went this way, and they went 70 miles per hour, and then on the way back they went 40 miles per hour. And the first question here is like, do you think that the average rate was 55? And they're essentially saying, is 40 plus 70 over 2 equal to 55? And you would probably think that it is.
Right.
Okay. Usually when you get questions like this, they're going to show you that it's actually not this in the end.
Yeah.
Okay. So we're
They
gonna
don't usually tell you the answer right off. They want to
yeah,
prove you wrong.
they want you to realize like, oh, it actually isn't. And this is actually a classic like exam, standardized test exam question that we're gonna look at. Okay, so let's look at the next section of information that's given. Make sure that this is it. Yeah, it means it's to show all work. I'm sure you know that. Okay, so there's this very, 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 very useful formula. Distance equals rate times time. And so each of the variables are defined here. D is distance, T is time, and R is the rate. Is that okay?
Yeah.
Have you seen that
I've
before?
seen that before.
Okay, so now I think we can get into step 1. And what I'll do to try to make this like as clear as I can is I will write on the actual picture so you can see what you would potentially want to write down as you're doing this. So set up an equation to represent the distance the cheetah covered in terms of T minutes running at a maximum speed. Okay, so the only sorry, I'm just reading the rest. Remember, units, okay, rate in miles per minute. Okay, interesting. Okay, so the distance is equal to rate times time. That's given.
Right.
Okay, and we know that the rate is 70 miles per hour.
Right.
But we want miles per minute. So we need to convert 1 hour into 60 minutes. Do you see how I did that?
Yes.
Okay, the hours cancel. Maybe if you've had a chemistry class or a science class, then you remember that, there's sometimes unit conversion problems that occur here.
Yeah.
Okay, so this becomes 70 over 60 miles per minute, but we can actually do one better. We can cancel out the zeros. So it's 7 over 6 miles per minute.
Okay, I see that.
Is that okay so far?
Yeah.
So now to finish out A, and again, you would definitely want to show all of this. I'll send you the PDF, of course, at the end, or you can get it down now. But the distance the cheetah travels is 7 over 6 times T, because this is R. This is the value of R. So this is like the final answer for A.
Right.
Is that okay?
That's what R is.
Yeah. Yes. R ends up being this number down here, 7 over 6. And so we substitute it back into the original equation.
Yes, that makes sense. And I got it all down. So.
Okay. Now part B, it says let T equals 10. Well, if T equals 10, we're putting 10 in for T.
Right.
Okay. Now, just off to the side here, remember the units of the rate is miles per minute. So if we multiply by minutes, do you see how those cancel?
Yes.
Okay, so whatever number we get here, 70 divided by 6, which reduces to 35/3. This is in miles.
Right.
And when you're doing these story problems, these word problems, you do care that it's in miles. This one.
To be clear. Yeah.
Okay, so that's clear. Let me go to step 2.
Mhm.
And let me snip this in. Always let me know if you need more time to copy something down or you need me to go back up.
Just catch up. Cool.
Okay. It says now, suppose the cheetah sprinted at a maximum speed for 8 minutes. So their maximum speed was 70 miles per hour, but we know that that's really 7/6.
Yeah.
Okay. And then it slowed to 40 miles per hour. So we need to convert that to miles per minute. And if, again, in 1 hour, there are 60 minutes. So it's 40/60, which is really 4/6, which is 2/3 miles per minute. Okay, so now we can actually answer question A. Some of this could have actually gone into part B, but it's okay to show it. Okay, so how far would the cheetah have traveled in the first 8 minutes? Distance is rate times time. The rate is 7/6. That's from the first part of the problem, times 8, because that's the time.
Right.
Okay, so that's 56/6, which is 28/3 miles. So when it says show how you arrived at your answer, they're just asking you to show your work.
Mm-hmm.
And if I'm grading it, I definitely want to see the word miles there.
Right, because it's important that they understand that it's going to be.
Yes, that it's a distance traveled. Okay, it next says how far would the cheetah have traveled in the next 8 minutes? So the equation is still distance equals rate times time. But this time the rate is 40 miles per hour, which we said converts to 2/3. So all this work over here could be down here for kind of for that part.
Okay.
And then times 8. Okay, because it's 8 minutes. So that's 16 divided by 3 miles. And hopefully you can see that, and this intuitively makes sense that the cheetah went further in the first 8 minutes than in the next 8 minutes.
Right.
And I believe part C actually, well, part C and D. Let me grab those two. And E. Wow, there's a lot here. Okay.
Yeah.
All right, let me grab just two at a time here and see if okay, it says how much further did the cheetah travel in the first 8 minutes than in the second 8 minutes? What we're going to answer that question, we take our results from the first two,
Mm-hmm.
28/3, subtract 16/3, which equals 12/3, which equals 4 miles.
Right.
Boy, that seems really fast. I guess not. They're going 70 miles an hour. I guess that's right. Sometimes the numbers, even to me, are just a little bit like, huh, really? Okay. The cheetah traveled 1.7 times. So now I'm on to part D.
Yeah.
Faster for the 8 minutes than it did for the second 8 minutes.
Why couldn't they just make it an even 2? I can never understand that.
Yeah, well, yeah, that's a different class, a different thing here. So they're saying that like 40 to 70 is a multiplier of 1.75. That's what they're trying to tell you.
Right.
Okay. Now the distance that it traveled at 40 miles an hour was 16 over 3. And then 28 over 3 is where it went. And they're asking, is this the same multiplier, basically? So let's talk about how they actually got this 1.75. They took the 70 and divided it by 40. That's 7 over 4, which does become 1.75. You can obviously put any of these into the calculator. So we're going to do the same thing down here. 28 over 3 divided by 16 over 3. And you may recall, when you divide by a fraction, you multiply by the reciprocal.
Yeah.
Okay. So the nice thing is the 3's cancel, and you get 28 over 16. That's 14 over 8. That's 7 over 4 also. You see that?
Yes.
Which is also 1.75. So they say, show the calculation to justify your answer. It's all here. It's just, was that too fast to see? But yeah, it is exactly the same.
Yeah, no, I see it. Sketching up slightly. All right. Gotcha. Cool. That makes sense. Yeah.
Okay, so I think we got one more part here, part E, before moving on to step 3.
Yes.
And just I didn't say it, but there's no units for this because the units end up canceling out. Like 70 over 40, they're both miles per hour, so they just cancel. So this is just a number.
Okay, that makes sense.
Okay. Okay. If the cheetah made a round trip and took half the amount of time on the return trip as on the front end of the trip, what would be the relationship between the average rates on each leg of the trip? Okay, so for example, I guess we've got to, so the rate is 70 miles per hour, which we've been converting to 7 over 6
Right.
miles per minute. And what they're saying here is that, like, pick a time. Let's say the time is, let's pick some nice numbers this time. Let's go with 6 minutes there. That's there. Okay. Now on the return trip, it's 40 miles per hour, which was 2/3 miles per minute. This is all review.
Yeah.
But this time the time is half the time the return trip. So on the return trip, the time would be 3 minutes. Now there's a problem here because you can't, if it takes you less time to get back, your rate has to be faster. So let me just not do this for the moment. Okay, we'll come back to that. Let's just call R your rate there. R1 is your rate there. And R2 is your rate back. So now, like under the first scenario, the distance there is your rate there times 6 minutes. Do you agree with that?
Yes.
Okay. And then when you're going back, your rate back is R2 and your time is 3.
Right.
You agree with that? It's R times T.
Yeah.
Now, this is key. Since you went there and back, you went from A to B, what do you know about the distance there compared to the distance back?
If you travel slower.
No, it's distance.
Oh, it would be the same.
It's the same. And since it's the same, you can set these equal to each other. You can say 6R1 equals 3R2.
Right. Makes
Okay.
sense.
Okay. Now, so let's solve for R2. R2, you're going to divide both sides by 3. R2 is 6 divided by 3, which is 2 times R1. So let's go back and summarize. And this is key here because this is what needs to make most sense. So I'm just trying to frame the picture here.
Mhm.
So when you went there, it took 6 minutes. When you went back, it took 3 minutes.
Right.
So if it takes you twice as long to get somewhere, that means that you must have gone twice as fast or half as slow, however you want to look at it.
Mhm.
So in other words, like let's say rate 1 was let's say over the 6 minutes, your rate was like 5. Well, then your rate back had to be 10 to cut it in half.
Right.
Does that make sense to you
Yeah.
intuitively?
Yes.
So it says using a complete sentence, explain how you arrived at the conclusion. This is probably the hardest part for you, but you'd want to somehow say, because for every student really, I mean, it's just hard to interpret these things, but you'd want to say that when the time is cut in half, the rate is doubled. That's kind of what you're looking for.
Okay.
Because and that's with these numbers, with this information, then it somehow is clear that you understand that's what's going on here.
Right. So they want a sentence, making sure in any
Yes.
situation
Yes.
that is able to do it.
Yes.
Yeah.
So your complete sentence though could say something like, if the time there was 6 minutes, then time there back was 3 minutes, and your rate there was 5, then your rate back had to be 10, meaning that if it took half as long, your rate had to double.
Right. Okay, that makes sense.
Okay, can we move on to step 3, part A?
Yeah.
All right. This problem actually feels like it's taking the long road to get to where you want to go. It's they're really making this complicated, but hopefully by the end, like it's all clear. We'll see here. So they want you to make a table. There's a row, and we actually kind of did this to the river, and then from the river. And we're going to read the prompt. I generally actually read the prompts after I've done whatever it says here. So that's a test taking strategy, is to go right to the thing they're asking for. And then we've got distance, we got rate, and we got time. Let T represent the unknown quantity in the problem, fill in the table. Okay, so again, assume that the cheetah travels an average of 40 miles per hour to go from its resting place to a rock near the river. So the rate to start out is 40. Do you follow that?
Yes.
Now, the reason we kept it in miles per hour, even though in the previous problems we changed it, is because they tell you to do it in, well, actually they don't say that, but time is in hours. So that's why you want to do it that way. Although, take that back here. Yeah, we'll do this for right now. We may have to change this, and I apologize. Sometimes I'm just guessing here what they want.
Yeah, that's fine.
All right, so now it says that T is the unknown quantity. Okay. On the return trip, the cheetah averaged 70 miles per hour. So that's 70. Here, let's just do this. Let's just convert these to those other numbers we were using in the previous problem, just in case we need them later on.
Yeah.
Okay. All right. Now, what they're telling you is that the total time the total time from A to B and back was 15 minutes. Okay, there and
Right.
back was 15 minutes. That's not in the right units. It kind of is. I mean, it is for these second ones, which we probably should use. But we don't know how much time it took to get there and how much time it took to get back. Do you agree with that?
Yes.
So you have to decide, do you want to call T? Do you want T to be the time it took to get there to the river, or do you want T to be the time that it took to get back from the river?
T to be the time it took to get there.
Okay, and truly it doesn't matter. So
Right.
let's say it took 5 minutes to get there. What's the other? How much time would go here? Because
10.
the total 10. So the way you calculate that is 15 minus T. Because if T was 2, you would tell me it's 13.
Right.
Right. And so coming up with this equation is the hardest part. You have to come up with the equation. I obviously did it for you, but you know, that is truly the hardest part here.
Right.
We don't know the distance, and it doesn't look like they. So there's a couple options here for this. This one is we could call their distance just D1. But we can also actually multiply these. So it would be like 2/3 times T.
Right, because that would be what the
Because the
equation
rate,
would
yeah,
do.
the rate, it's rate times your rate times your time. And then this other one would be 7/4 parentheses though, 15 minus T.
Right. That makes sense. That's how you would do the problem.
Okay, so part B, we can move on to part B, which is, they give you a lot of room for part B, but you actually need more of the room for part C. It says from the table, set up an equation relating their distances. So as you mentioned before, the distance there equals the distance back.
Yeah.
Okay, and that's a huge assumption here. It's like when you go to Phoenix, however many miles you or wherever you're going, however many miles there, it's the same as how many miles back. Okay, so your D1 in this case is 2/3 T equals 7/4, 15 minus T. And that's it for part B.
Okay.
Because they say here to just set up. Set up means write the equation. It means don't solve, just set it up, see what you get.
And then they're gonna have me solve it later on.
Yeah, about as much time as it takes me to snip in the next part of this. Yeah, it's very predictable. But maybe there's some real learning happening here where you actually kind of understand this. So solve the problem here. So what they really mean is to figure out T, solve for T. Okay, so this is going to take some steps here. And unfortunately, there's fractions. There's a lot going on here. All right. So when you look at 3 and 4, these are the fractions. What is the least common multiple of these two numbers?
12? Oh, at least
it's 12. Yeah, it's 12. Perfect. Okay. So if you multiply both sides by 12, okay, you multiply both sides by 12, you will clear the fraction. Now on the left, it's a little bit easier. Now I know the tendency is to multiply before and then divide. It's actually better if you divide first. What is 12 divided by 3?
12 divided by 3 is 4.
4, and then you multiply the 2 by 4. So that becomes 8T. Let that sink in for a moment. It's you divide, because if you multiply, we'll do the multiply just so you can see 24 divided by 3 is 8. If you divide first, the numbers get smaller, and that's why it's
that makes more sense. It's like a shortcut almost.
Exactly. Now on the left here, and this is hard to understand, but I'm gonna have to try to get you to buy into this. There is one term here, which means this 12 can only apply to this right here. It does not apply to this other stuff, even though you may think that it does.
Okay, so we don't have to touch the 15 minus.
No, and the reason, here's the example: 4 times 5 times 6. You let's say you multiply the 6 times the 4. right?
Right.
You don't then multiply by the 5, do you?
No.
No, of course not. And that's what's happening here.
Okay.
Okay, so again, I want you to divide first. What is 12 divided by 4?
3.
3. 3 times 7 is 21 times 15 minus t.
Okay. Yeah. I get
Okay,
that.
so again, if you can, I mean, it's one of those things like if you can remember it and do it and believe it, you will save time on tests by dividing before you multiply.
That will take a little bit relearning because I always did it the other
Sure.
way. But it makes a
Yeah,
lot more sense to do it
it
that
does.
way.
Yeah.
Okay.
Okay, so now we actually do have to distribute in this 21. Let me not do that. So yeah, we're gonna have to just multiply it. I mean, and the numbers aren't great. So 21 times 15, 20 times 15 is 300.
Mhm.
And then you have 1 times 15, that's 15. So that's 315 minus 21t.
Right.
And then you have 8t over here. So we're going to add 21t to both sides. So we have 29t equals 315. And unfortunately, this does not work out very
Yeah.
nicely at all. I am a little shocked here. Let me just double check this
Mhm.
because I mean, I do make mistakes, and what's important here is that you get the right answer, because I assume you're turning this in for some sort of credit. So
Yeah.
let me take a look here and see if I can get it. So 2/3. Yeah, so this is correct. It just it's not nice. It's not a number that t equals 315 over 29. If we approximate that, it's a little bit less than 11. It's 10.9, I'll say. Actually, let me go out a little bit more for this. It's 10.8621. So we're going to need those decimal points, and that's in minutes.
Right. Because we're in minutes, not hours anymore.
Yeah.
We converted
Okay.
it.
But okay, it says to state the answer in terms of minutes and seconds. So there's actually a little bit more work to do here, because when you tell someone you're going to be there in 10 minutes, you mean 10 minutes, but 10.862 means, well, there's some amount of seconds. Okay, so the way that you convert this to seconds plus minutes is for sure that it's 10 minutes.
Right.
Okay, but that means it's this 0.8621 minutes. And just like we did earlier, in 1 minute, this is a unit conversion, there are 60 seconds. So do you see how the minutes now cancel? If you multiply this number times 60, you will get the number of seconds. Like, and let me just try to explain this another way out the side. Let's say I said it was 0.5 minutes. Okay. And if you said, oh, well, 1 minute is 60 seconds. What is half of 60?
60, 30.
30 seconds.
Right.
Okay. So it's the same idea here. It's just not a nice number. And
Yeah.
the more math you take, the less you have these kind of nice numbers here. So this is approximately 52 seconds.
Okay.
Okay, now it does want to. So the reason it wants a complete sentence, if you go all the way back, I know this is a lot, but I'm just try to, you can listen to this later, but we set t to be the time to the river.
Yes.
So we want to say that the time to the river was 10 minutes and 52 seconds.
Right.
But is that what it's asking for? It actually wants to know how much time did the return trip take. So this problem actually wants the other one. So we have to subtract this from 15. So 15 minutes and this is the, you know, the oddity of our system, 10 minutes and 52 seconds. If you add 8 seconds, how many minutes does this get us up to? If you add 8 seconds to it?
Oh, that gives us to 11.
11. And so that's 4 minutes and 8 seconds is the time back. So your complete sentence here is it took the cheetah 4 minutes and 8 seconds to return from the river.
I caught it.
Okay. And do you feel comfortable with
Yeah, I understand how we got to that. Or at
okay,
least I have the way that we got to it, so I
perfect.
can look back on it.
Perfect. Now does it intuitively make sense that, so see how, sorry, I know I'm jumping around. Let me go back to the question. Does it intuitively make sense that since it was slower to get there than it was on the way back, that it would take more time to get there than it does to get back? Does that make sense to you intuitively? Like if you walk to, I don't know, the end of a long driveway, or you could drive back from the end of a long driveway, does it make sense that like walking would take
Yeah.
longer than driving, or, you know, any
Right.
other type of situation you can think of here?
Yes, it does.
Okay. All right, so now let's go to this. Do you have to type your solutions, or do you
I'm just writing it on it. My teacher said I can do whatever. I can type it, scan it.
okay. All right. Well, good. All right. So 4, calculating the average rate. So basically everything from here on is what I call symbolic, and it means that there are no numbers. And as a student, I didn't like this. I don't expect you to like it, but there are no more numbers until the end. So you do the problem without numbers, and then you work it through.
Yeah,
Okay.
I not like the ones without numbers.
Yeah.
I understand what you're saying. I know the problems.
Right. Okay, so the part A is saying the average rate for the trip is equal to the total distance traveled divided by the total time.
Mhm.
Okay, so they're telling us up here the total distance traveled divided by the total time traveled. So the distance there is D, the distance back is D, and R1 and T1 and R2 and T2, those are the rates there and the rates back, and the time there and the time back. Is that
Yeah.
okay? Okay.
Yeah.
So the total distance, we'll just do this in pieces. The total distance is D plus D, because it's the distance there and it's the distance back, and that makes 2D.
Right. Yes, that makes sense.
Now the time there and the time back, that's actually given.
Mhm.
Okay, the time there is so if we want to divide this by the total time is T1 plus T2. But since they are not the same subscripts, you cannot actually combine them. So you have to leave it like this: T1 plus T2. Is that okay? Is that okay so far?
Yeah, I understand that. Like combining X plus B or whatever, it just doesn't work.
Yes. Okay. Now we're going to go just a tiny bit further here. we're going to look at this first equation, this one right up here. If D equals R1 T1, and I ask you to solve for T1, you would divide both sides by R1. Do you see that?
Yes.
So T1 equals D over R1. Is that clear? Is that okay?
Yes.
Now I could similarly look at the second equation and say D equals R2 T2. And I could ask you to similarly solve for T2, which means you're going to divide both sides by R2. The R's cancel. T2 equals D over R2.
Yeah.
Okay,
Yeah.
so now going back to this equation right here at the top, what could we put in for T1 instead of T1? Instead of T1,
D divided by R1.
yes.
Cool.
Plus, instead of T2, we can put in
D divided by R2. Okay.
Now these are the same. This one on the left and this one right there, exactly the same. Okay, but
Mhm.
this one's in terms of time. This one is not. There's no time in this other problem here. Is that
Right.
okay? Is that okay?
Yes.
Okay.
Yeah.
So in some ways that's kind of what B is asking you to do. I'm going to snip in B now. I would show all this work for A if you have or have not done that. You definitely want to do that here for so it's asking you, is this the equation you got? And the answer is yes, but it could also be, but you could also get this other one, right? This one up here, 2D over T1 plus T2.
Right.
Okay. So what your instructor is trying to show you here is that like the average rate can be in terms of distance and time, or it can be just in terms of distance and the other rates. See how there's no times on this one on the left, but there's time on this one on the right.
Yeah.
Yeah. So sometimes like in a scenario, you know, one thing or another. And I think maybe that's the point here. So you could say, yes, it's equivalent. But this is also true because as you saw, they're just one is solved for the variables versus the other.
Right. It is doing more of the work.
Yes.
Still works. Okay. I caught up.
Okay, perfect. So the next one here is we have to write an algebraic justification for each step. Okay, it's not too bad, but let me try to show you here. So they're basically saying like they're saying this is where you started, this is where you start, and this is where you finished, and they want to know, well, what did you do? What did you do to go from one to the other?
Yeah. Okay.
So on the left here, see how the top is the same. Let's start with the same. The top is the same each time. So there's nothing on the top. Now on the bottom, and I'll show you what they're doing here. What they're doing is, and then we'll come up with some words here. D over R1, D over R2. They are making a common denominator on the bottom, and they're doing that by multiplying the top and bottom by R2 and the top and bottom over here by R1.
Okay, that's what they did.
Yeah, so somewhere you want to say something like common denominator. That would probably be good. Another thing they're doing here is they're combining the like terms on the bottom. So let me just rewrite this later. So this top here, dr2 becomes r2d over r1 r2 plus r1d over r1 r2. And see how the numerators are combined here?
Yes.
They're combining these numerators also. So that's maybe the second thing here is you can say combine numerator.
So this, yeah, I've seen this before and I've always had a hard time explaining, but I did to solve the problem.
Yeah, and there's quite a bit happening here. Okay. Yeah, so here we go. Let's keep going here. So the next line that we're going to look at, let me know when you get all this down. We'll go on to the next line.
Just give me 2 seconds.
Sure.
Okay. Top.
Okay, so then part or the next kind of step here, this is still part C. This is all part C, just in case it's not clear. So it says that what they want to know is like, well, how did you go from this right here to this right here? Okay, and the answer is the way you want to answer this is that when you have a fraction that you're dividing, it becomes multiplication. We did this earlier. Multiplication right there times the reciprocal. So right here, what I'm boxing in and what I'm boxing in here, these are the flip. They're the flip of one another. Do you see that?
Yeah.
So what was on bottom goes up top. What's on top goes to the bottom. So then to go to the next step, which I would just call it a rewrite, but you are literally multiplying the numerator and then the denominator.
Okay.
So like 2D times R1, R2, you just squeeze all the numbers or the letters together. 1 times the bottom just becomes the bottom. So get this down, and then we got one more line to go, and then the last part we should be able to just finish everything today, which I'm sure will be great.
Yes, that would be great. I did not think that I'd be able to do that because of how big this thing was.
Yeah, it can feel overwhelming as a student seeing something like this. You're like, oh my goodness, how am I going to do this? And you're not alone. A lot of students feel that way.
Okay, I got it.
Perfect. Okay. All right. So next part here, I think I got it. Yeah, there it is. Okay. So again, the question is like, well, how did you move through these steps here? So notice this is the line from the previous step. So to go to here, notice that the top is the same, but the bottom, in the bottom, there was a D in both terms, but now it's on the outside of the parentheses. You factor out D.
Okay.
And then what do you?
How we factor out the odd in other situations.
Yeah. Yep. So now what is missing? What is no longer here that was here in the previous step?
D.
So the next thing is you cancel, or the correct word is divide out D. So that's 1 and that's 2. So the point here, which like we really could have made it in a simpler way, is we could have just said, hey, your average rate actually does not depend on the distance. It only depends on the individual rates.
Right.
because there's no distance in the final equation. Have you taken a physics class yet, or?
No, I have not.
Okay, now I'm not suggesting that you do that. You may enjoy it, you may not, but a lot of times in physics, a lot of the quantities cancel out that you might think matter, but they end up not mattering at all.
Okay.
Okay. Another thing is to notice that this also does not depend on time.
Oh yeah, it doesn't, because time has been out of
Yeah.
the equation for a
Time's
while.
out of there. Yeah, and it's kind of a neat thing, but we could have maybe said this a little bit more compactly. So here's the equation. So
Mhm.
rate one is the, I think it was the 40 miles per hour, which we said was 2/3. And then rate two is the 70 miles per hour, which we said was the 7/4. You actually could use either here.
Right.
You could use these or these, but let's just use the numbers we've been using. 2 times 2/3 times 7/4. I know the fractions are awful, but we're going to just deal with them. And then it's 2/3 plus 7/4. Okay. So in the numerator, we can just multiply the tops and multiply the bottoms. So 2, this is written really poorly. 2 times 2, 4 times 7. So it's 28/12 over. Now on the bottom, our common denominator is 12. And our numerators is 8 and 21. So this becomes 28/12 over 29/12. Whenever your bottoms are the same, you can just go with 28/29 as your
Right.
canceling here. But this doesn't mean much because this is in miles per minute. So to clean it up, we can go backwards. We can say that there are 60 minutes for every hour. So, or we can just leave it like this and say, this is the correct answer. It actually doesn't say, like, it doesn't tell you, oh, put the units back in miles per hour. But if your instructor wanted that in miles per hour, you would do the following. You would say there are 60 minutes in 1 hour, and then your minutes cancel and you get this new quantity.
Right.
And let me just do that here with a calculator here. So it ends up being that's 57.9 miles per hour. And remember, the original question was like, is it 55? And I said, it's no, and it's actually going to be a little bit bigger.
Yeah.
And that actually it tends to be always true. If you go the same distance there and the same different distance back, the average will actually be faster than the average of the two numbers.
Right.
Okay, well, I think that is it for tonight. I think we got everything in that you wanted to work on.
Yeah.
I will send you the notes here shortly, and I'll see you next time, whenever that is. Hope you have a great night and weekend.
Yeah, you too. Thank you.
All right, you're welcome. Bye now.
Bye.